So in the previous video, I explained about the first case. In the first case, we have considered the J unit, that is nothing but an hidden unit itself as an output unit. Now here in the second case, here we are considering a hidden unit. So we know that an I layer, it is an input layer, J layer, it is a hidden layer, and a U layer, it is an output layer. So in the previous video, I have explained the derivation of a backpropagation algorithm. The main agenda was there to find out the delta Wi value. So this is a delta Wji value. We are finding it out. So here we have minus eta. Eta, it is a learning rate, and a negative sign it is because we are finding out a global minimum error, and delta Ed divided by delta Wji, we need to find it out. So in order to find that, in the first case, we have considered an J unit as an output unit and performed the derivation, and we got this output when J unit is an output unit. Now, while performing the backtracking, we are considering a J unit as an hidden unit. That is, in a backpropagation algorithm, I have explained here, this is an I unit, that is an input unit, J unit is a hidden unit, and U unit is an output unit. When the error we have got, and when the predicted value it is not equal to an actual value, we are going to backpropagate and update the value of an weight. So the weight is updated as Wi plus delta Wi. So when we backpropagate it, we have an output layer, and from output layer we are going to move to an hidden layer, and from the hidden layer we are going to move to an input layer and update the weights at each and every step. So now the second case, derivation of delta Wi, it is a case where we are considering an hidden unit J as a hidden unit, and it is for backpropagation. So we know that delta Ed divided by delta net J, we have to find it out. From where we have got is, we considering an equation number 3. So here, considering an equation number 2. In this, we have considered the first case. To find out this delta Ed divided by delta net J, we have considered the first case, and now we have to consider the second case, and we have to find out the value of delta Ed by delta net J and substitute the values to equation 2 and 1 in order to get the value of delta Wji. So now delta Ed divided by delta net J, it is equals to summation of k belonging to downstream of J. So k, it is an output layer, number of output units that is present. Here we have 3 output units, or the 3 neurons that is present. So k belonging to downstream of J. The downstream indicates that it is a backpropagation to an hidden layer J. Delta Ed divided by delta net k into net k. So for this equation, we are going to multiply and divide by delta net k. So why we have considered the delta net k is, when performing the backpropagation, so this is a k output units that is present. So we are backpropagating, and we have considered in the case 2 as this as a J as a hidden layer. So since we are backpropagating or downstreaming, we need to multiply and divide by delta net k. So that's why I have multiplied and divided here by delta net k. So now when I multiplied and divided, so we know that delta Ed divided by delta net k, it is nothing but minus delta k. So the minus delta k, it indicates that it is a backpropagation constant. And negative sign here, it indicates that it is a downstream or backtracking or backpropagation. So the left out here is delta net k by delta net j. So we know that the net is influenced by an output. So we know that output, that is Oj, it is nothing but the sigmoid function of the net value. So that's why, so net is influenced by an Oj. So that's why we are multiplying and dividing this term by an delta Oj. So when it is multiplied and divided, so we are going to get like this. So delta net k by delta net j into delta Oj by delta Oj. So when it is written in terms of a chain rule, that is delta net k by delta Oj by delta net j. So this remains same. This remains same. Delta net k divided by delta oj, it is nothing but the weight, and delta oj divided by delta net j, it is nothing but, so we know that oj, it is nothing but the sigmoid function of net j. So when we perform the differentiation of a sigmoid function, we are going to get delta of y into 1 minus delta of y. So here in place of y, we have net j. So and net j, it is influenced by oj. So that's why I have written here oj into 1 minus oj. Why? Because we know that oj, it is equals to, we know that oj, it is equals to delta of net j. So that's why I have written here oj into 1 minus oj. So this negative sign here just indicates that it is a back propagation. So now if I replace the term, that is delta ed divided by delta net j, we know that here delta ed divided by delta net k, it is replaced by an backpropagation constant delta k. So the same way delta ed divided by delta net j can be replaced by a backpropagation constant delta j. So the same thing, it has been replaced here. So it has been replaced how I have replaced here. It is a backpropagation constant. So here also it is replaced by delta j. So now delta j, it is equals to, so this is a constant value, I can take it outside. So it is minus, so this negative sign will come outside, just indicates that it is a backpropagation, and oj, it is coming outside. So minus oj into 1 minus oj downstream, delta k into wkj. Wkj, it is a weight that has been updated from an output layer to an hidden layer. K indicates an output layer and J indicates an hidden layer when backpropagated. So next put equation, this equation 9 to an equation 2. So what is our equation 2? So this is our equation 2. We got the value of del ed divided by del net j. So when I substitute it, so I am going to get it as this value. So I have just substituted minus, so this minus I have taken this side, and I have substituted the value as minus delta j x ji. I have just substituted this value completely. I have not written here. If you want, you can write completely or just replace it with this value. So I have just replaced here into xji. So now, so this is my equation 10. So what is the main agenda?